Okay, for what we have in section 8.2, we have a couple of problems where each is going to be a system of three equations. Okay, and in number one, we're looking at solving for x, y, and z. And looking at what we have among the equations, we have negative 3z is equal to negative 9. Also, we have 3y plus 5z is equal to negative 3. And we have negative 2x plus 2y plus 5z is equal to negative 3. So we're looking at the values of x, y, and z that will agree with all of these equations that we have. And looking at what is likely going to be the easiest to solve or what is going to be the solvable equation right away. We have negative 3z is equal to negative 9. So we can solve for z right away. And we have, with division by negative 3 from the first equation, we have that z is going to be equal to 3. And I can carry this over and go ahead and solve for y. So we have for the next equation, we have 3y plus 5z is equal to negative 3. And having already solved for z in the first equation, I can relay this over to the next equation, solving for y. So you have 3y plus 5 times 3 is equal to negative 3. So you have 3y plus 15 is equal to negative 3. And taking what we have now, as we deduct 15 from both sides, so we will have 3y is equal to negative 18. And we have a division by 3. Okay, we're going to have that y is equal to negative 6. So we have z at 3, y at negative 6. And now I can solve for x. And in the equation, so we have negative 2x plus 2y plus 5z is equal to negative 3. And so, again, I can just sort of relay and substitute. So you have y at negative 6. And again, we had z at 3. So we now have negative 2x and 2 times y, so we have 2 times negative 6. And we have 5 times z, okay, so you have 5 times 3. So we now have negative 2x minus 12. And we have plus 15 is equal to negative 3. Combining, okay, so you have negative 2x plus 3 is equal to negative 3. And if I combine the constants together, so we're going to have negative 2x is equal to negative 6. And with x, we have negative 6 divided by negative 2, so that will be a positive 3. Okay. And so we have, in this particular regard, okay, right. So we're going to have x at 3, y at negative 6, and again we have z at 3. So we have in the solution, we have x is equal to 3, y is equal to negative 6, and again we have z at positive 3. Now for what we have in the second system, we have 3x minus y plus 2z is equal to 3. And we have x minus 2z is equal to 12. And we have 4x plus z is equal to 12. And you can use either methods of substitution or the addition method in solving for x and z. Okay. All right, so if you notice the second and third equations we have in terms of the variables x and z. Again, we have x minus 2z is equal to 12. and we have 4x plus z is also equal to 12. And what I can do, if I apply the addition method, I can eliminate one variable and solve for the other. So here we have x and 4x, and we have negative 2z and z, and each equation we have set equal to 12. Now I can either eliminate x and solve for z, or I can do it the other way around. It doesn't matter. We'll go ahead and solve for z. So that which will eliminate 4x will be negative 4x. So if I change the x to a negative 4x, what I'll have to do is to keep everything in proportion and intact. So I'll just multiply the first equation by negative 4. So for the first equation, we're going to have negative 4x. Then I have negative 4 over negative 2z will be a positive 8z. Negative 4 over 12 is going to be a negative 48. All right, so you have this first equation, but with everything multiplied out by negative 4. And then just duplicating the second equation. So I can now add the equations together. So we have negative 4x plus 4x goes out. 8z plus 1z becomes 9z. Negative 48 plus 12 becomes negative 36. And solving for z, if I divide by 9, we have z is equal to negative 4. And again, I can take either equation and solve for x. So we had x minus 2z was equal to 12. And if I take what I have for z, so I have upon transferring, so we have x minus 2 times negative 4 is equal to 12. And here we have negative 2 times negative 4 is 8. X plus 8 is equal to 12. And so we have with the resulting solution for x, okay, that is going to be at 4. So you have x at 4, z at negative 4. And if I take the values that we have for z and x and solve for y, which was present only in the first equation, which we had at 3x minus y plus 2z is equal to 3. And again, just filling in, so you have x at 4, and we have z at negative 4, so we have for 3 times x, so you have 3 times 4 minus y, and 2 times z, we have 2 times negative 4, we have is equal to 3, so you have 12 minus y minus 8 is equal to 3. And here we have 12 minus 8 is 4 minus y is equal to 3. And getting y by itself, so if I take 4 away from both sides, okay, so we have negative y is equal to negative 1, and with either multiplication or division by negative 1 on both sides, okay, this will just revert to a sign change on both sides, whereupon we have y equal to 1. So we have, in this case, all right, so we have x at 4, y is at 1, and we have z at negative 4. So we have for the end result here, so we have x equal to 4, y equal to 1, and again we have z at negative 4, and that will be the solution set in this case.